In the theory of horsepower, the more air and fuel that you can force through a given engine will create more horsepower. Therefore, a 125 engine creates more horsepower than a 50cc because more air goes through the intake of the carb, through the reed cage right here, through the engine right here, into the larger cylinder right here, and out the larger exhaust. Now, all of these parts are not put together, you buy them out of a magazine and they just work. Everything has a trade-off. Our trick is to make sure that we have a free flow of air from the beginning of the combustion process, which is the intake right here. I'm standing outside. I got better light out here. To have the air go through the intake in a free flow, to go to the reed cage, into the cylinder right here, and out through the pipe right there. The more air and fuel that we can put through there, the more horsepower you're going to have. Herein lies the problem. Suppose that we put this big giant carburetor on a stock DIO or Elite engine. It won't work. It'll flood it out. Why? Because the engine is not designed to take this much gas and air. So we want to have an equal, try and make an equal amount of air coming from the air filter out the carb, into the reed cage, into the engine, and out the exhaust. What we have here is this. The theory of horsepower states, all right, now this is going to be, this is for all you young guys out there, or anyone that doesn't understand exactly how these engines work. All engines work the same. They all have the same benefits, but they do have the same problems. This will help you in designing an engine, a racing little motor. Okay? Now if I have $50,000 in US, I could go right down the road right now and get a brand new Kawasaki H2 300 horsepower turbocharged, fastest bike in the world. But we're not talking about that. We're talking about trying to get horsepower out of these little engines. So what we have here is this. We have a large carburetor right here. Let me move that, excuse me. We're going through an intake system here, and preferably the intake system should be as free-flowing as the carburetor. We go into the CT manifold right here, and this is where it starts to create a bottleneck, because this right here is the intake for the 33. It goes on to an intake that, as you can see, you see how it narrows right there? Well, that's no good, because the large part covers the carburetor. The smaller orifice right here is only as much air as you're going to get. So this is too small, or it's a choke point. It's basically like this. We have our carburetor, our intake, our reed valve, and then we have our engine. And consider these airflows right here, from here to here. Well, we have a bottleneck right there because we have a small intake. Your carburetor system, from your carburetor to your intake to your reed valves into your giant cylinder and out your racing pipe, is only as large as your smallest part of the motor. So we have this that creates a problem. And I believe that this is slightly smaller or larger than this right here. But where our real problem lies is right here. You see those little tiny holes that go into the engine? These are designed for 50 cc's right here. This is molded in. You can see down here. They're molded into the block right here. And if you've ever torn down a CR125 or KX125 or any motocross 125, you will notice that they have a huge intake right here. The 125 is still running into 125 cc cylinder right here, just like we're running. But this is where the choke point is, right there. The trick is to get these as big as you can, but also to realize that you can't put a 500 cc cylinder on here and a 500 cc pipe and a 38 or 44 millimeter Sudco carburetor on these little engines and expect them to work. They can't do it because of this choke point right here. This choke point is in two places. If you consider, let's just consider this is your intake, this is going into your engine, and your exhaust is right here. So what we have to do is fix this little problem right here, which is partially right here, which goes into the engine, and partially right here. And then on future videos, I'm going to see if I can find a way to fix that. This area right here, I don't know if it can be done, but that's all part of the fun of having these little bikes, because your crankshaft, your left part of your crankshaft sticks out right here, your variator runs right here, your nitromethane injectors are right over here. Got to keep you interested in the videos. And if I was a welder, I may change something on that if I could, but it would probably hit the it might hit the crankshaft right there. But that's the fun of building these little mopeds, is that we can put on all these really neat racing parts and see what happens. So what I found is, if you go on the internet, you know, that airplane shouldn't really be in my video. I'm going to complain. Assholes. I went on the internet and I looked at Everett Power Sports, and actually it's in my home state. And as you can see, this is a new intake manifold carb boot for 40 millimeter outside diameter carb, which this is what this is. This is 40 millimeters outside diameter. So that's what you need to find. What I found that'll work on my carburetor system is the black manifold right here. I can't even put it right. Anyway, the black manifold goes like that, and this boot will fit right on top of it, and I'll have to do a little bit of adjusting with the, I'm going to widen this for the bigger carburetor. So I hope that you can hopefully understand a little bit better about the theory of horsepower and how it works. Now, these are normal aspirated engines. If you're talking about turbocharged or supercharged, what it means is pushing more air and fuel through the engine by mechanical means than naturally aspirated, or what the engine can do by itself. That is why a supercharger or a turbocharger creates more horsepower by forcing more air and fuel through the engine from the carb into the cylinder all the way out the pipe, creating more horsepower. And I hope that it helps all you new young guys out there that have started to build these engines. And remember that if you know more about this, please don't comment, because I'm an American. I know everything, and I have a really big dick. Rock on.